Hello guys, welcome back to Husky Math. We will be solving a set of model questions for upcoming third semester maths examination of West Bengal Council of Higher Secondary Education. In this set of model question, there are 40 questions in total, all MCQs. So let's begin question number 1. So here, let R be the relation on the set of R. This capital R is a set of real numbers, and there is another R that is relation on this set of real numbers, and this relation is defined by A is related to B if and only if modulus of A minus B is less than or equal to 1. Then we have to check whether the relation is reflexive, symmetric and transitive or not. So let's check whether it's reflexive or not. For that, let us assume an element A from real number, and we know that modulus of A minus A will be equal to modulus of 0, and this will be equal to 0, and 0 is always less than or equal to 1. That means here we conclude that A is related to A. That means all real number is related to itself in this relation. So that means this R relation R is reflexive. Second, let us check whether the relation R is symmetric or not. For that, let us assume an element A comma B from the relation R, then A will be related to B, and from the definition of relation, modulus of A minus B is less than or equal to 1. Now here let us take out minus common, then it will be B minus A, which will be less than or equal to 1. And this implies modulus of any negative number will be positive, so we can write modulus of B minus A is less than or equal to 1. So from here we see that B is also related to A. So here if we see that if A is related to B, then B is related to A. That means this relation R is symmetric. At last, let us check whether the relation is transitive or not. See, by now I'm sure that the correct option for this question is option D, that is reflexive and symmetric. But since this is a kind of revision also, so we will be checking whether this relation is transitive or not. For that, let us assume two elements A comma B from the relation R and B comma C belonging to R. That means A is related to B and B is related to C. And from the definition, we see that if A is related to B, then modulus of A minus B is less than or equal to 1, and modulus of B minus C will be less than or equal to 1. Now, if I add these two inequations, then we will have modulus of A minus B plus modulus of B minus C, which will be less than equal to 1 plus 1. So on simplifying it, we will get modulus of A minus C, which will be less than or equal to 2. Now since this does not fit the definition, because in the definition there is less than or equal to 1, but it's coming less than or equal to 2, that means from here we can say that A is not related to C. That means the relation R is not transitive. R is not transitive. So yeah, this is not an equivalence relation. This relation is only reflexive and symmetric. So my correct option would be option number D, that is reflexive and symmetric. Let's move to question number 2. There's a function from a set of positive real numbers to set of positive real numbers. So here domain is positive real numbers and codomain is also positive real numbers. And the function is defined as x divided by 1 plus x. Then we have to check whether f is 1, 1 or onto or not. So let's check. So in order to check whether f is 1, 1 or not, so let f of x1 equals to f of x2. So from the definition, if f of x is x over 1 plus x, then f of x1 can be written as x1 by 1 plus x1 equals to x2 over 1 plus x2. Let us cross multiply. X1 plus x1 x2 equals to x2 plus x1 x2. So here x1 x2 gets 0. So we will remain with x1 equals to x2. Now since I have assumed that if f of x1 equals to f of x2 and we have arrived at x1 equals to x2, that means this function f is 1, 1. See, in order to prove the function 1, 1, we can use the derivative also, okay? But I'm doing like this here. Now let us check whether the function f is onto or not. So for that, let us assume fx as y. That means y can be written as x over 1 plus x. Now I will try to express x in terms of y. So for that, let us cross multiply, then we will have this. Let us bring xy here, will be equal to y. Taking out x common, then it will be 1 minus y equals to y. So this implies x equals to y over 1 minus y. Now, as you can see here, in this fraction, in the denominator, we have 1 minus y. See, it is clear that y cannot be equal to 1, because if it is equal to 1, then denominator will be 1 minus 1 and it will be 0, which we do not want. Okay. And in fact, the value of y cannot be more than 1 also. Why so? Because if you put the value of y as 2, then it will be 1 minus 2, and 1 minus 2 is a negative number. That means we will get a negative value of x. But x is our domain, and in the domain we see that our domain was the set of positive real numbers. So that means the value of y can be 0 and open interval 1. That means the range of f. That means the range of f. See, this y is the range actually. So range of f equals to 0, 1. But my codomain of f was 0, infinity. That means the range of f and codomain of f are not equal, which concludes that f is not onto. Okay, so correct option here would be option number A. This function is 1, 1, but it is not onto. Let's move to question number 3. So here f is a greatest integer function and g is the modulus function. So everyone knows what modulus function is. So I believe that you all know what a greatest integer function. Okay, so we will do while solving the question also. Okay, so then we have to find the value of g of f of minus 5 over 4. Okay, so let us find the value of g of f of minus 5 over 4. Okay, so if I convert this 5 over 4 into decimal, then it will be 1.25. so that means this is g of f of minus 1.25. so this can be written as g of f of minus 1.25. so this will be equal to g of c. From the definition, fx can be written as bar of x. So here I can write as minus 1.25. So the greatest integer function of this number would be, so for that let me draw a number line. So in a number line, so minus 1.25 will be somewhere over here, 1.25 minus 1.25. Now here you see that the integer which is less than minus 1.25 are minus 2, minus 3, minus 4 up to minus infinity. But out of them, the greatest one is minus 2. That means the greatest integer function of minus 1.25 is minus 2. So it will be g of minus 2. Okay. Now since g is a modulus function, then this g of minus 2 can be written as modulus of minus 2. And the value of modulus of minus 2 is equal to 2. That means the correct option for this question is option number B, that is 2. So here, if cos inverse of x plus cos inverse of y plus cos inverse of z equals to 3 pi, then we have to choose the correct option. Now for this question, we need to know the range of cos inverse function. So the range of cos inverse is from 0 to pi. This means the cos inverse functions can take the minimum value of 0 and it can take maximum value of pi and any value between 0 to pi. But here as you see that cos inverse of x plus cos inverse of y plus cos inverse of z equals to 3 pi. That means all these three terms should be pi. Only that time pi plus pi would be 3 pi. So that means cos inverse of x equals to pi. This implies x equals to cos pi, and that means the value of x equals to minus 1 because the value of cos pi is minus 1. Similarly, cos inverse of y equals to pi. So from here also y equals to cos pi and y equals to minus 1, and similarly the value of z will also be minus 1. And it is clear that my option B is the correct answer because here it's x plus y plus z. That means if you add x, y and z, you will get minus 3 plus 3 will be equal to 0. Okay, again the question from inverse trigonometric function. If sine inverse of x plus tan inverse of x equals to pi over 2, then we need to find the value of 2x square plus 1. So let us start from the given equation. So here let us take sine inverse x to other side, then it will be tan inverse of x equals to pi over 2 minus sine inverse of x. Now this implies tan inverse of x equals to, see, pi over 2 minus sine inverse x is cos inverse of x because there's a relation that sine inverse of x plus cos inverse of x equals to pi over 2. This implies tan inverse of x equals to, now we can write cos inverse of x in terms of tan inverse of x, and from the relation it is tan inverse of root over 1 minus x square over x. So since both sides there is tan inverse, so operating with tan we will get x equals to root over 1 minus x square over x. On cross multiplying we will get x square equals to root over 1 minus x square. Now let us square both sides. Then squaring both sides we will get x to the power 4 equals to 1 minus x square. Let us take all the terms on the left hand side, and it will be x to the power 4 plus x square minus 1 equals to 0. Now let us try to solve this biquadratic equation with the help of Sridhara Acharya's formula, and here my variable would be x square. So the value of a, b and c are 1, 1 and minus 1 here. So by using Sridhara Acharya's formula we can write x square as, see, we are solving in terms of x square, okay, because this x to the power 4 is x square whole square. So my variable is x square here. So minus b is 1 plus minus square root of b square means 1 square, that is 1 minus 4, a means 1 and c is my minus 1, whole divided by 2a, 2 times a is 1. So this implies x square equals to minus 1 plus minus, on simplifying we will get 5 inside under root divided by 2. Cross multiplying 2x square equals to minus 1 plus minus root over 5. So this implies 2x square plus 1 equals to plus minus root over 5. Now as you can see here, this 2x square, first of all x square is a positive number because there is a square, and multiplying a positive number with 2 will give you a positive number, and positive number plus 1 will always be a positive number. That means we will not write the minus sign here. So this would be 2x square plus 1 equals to root over 5, and hence the question we need to find the value of 2x square plus 1, so the value is root over 5. That means the option A is the correct answer. Let's continue question number 6. We have to find the principal value of sine inverse of sine 4 pi by 3 plus cos inverse of cos 4 pi over 3. For this we should know the principal value range of sine inverse function and cos inverse functions. So the range of sine inverse function is from minus 90 degree to plus 90 degree, and the range of cos inverse function is from 0 to pi. That means the value of those sine inverse and cos inverse should lie within this range. Okay, so here the first part, that is, let us first find the value of sine inverse of sine 4 pi over 3. So here it will be sine inverse of sine 4 pi by 3. Now we cannot directly write the value as 4 pi by 3 because 4 pi by 3 does not lie in its principal value range, that is minus pi by 2 to pi by 2. So we need to modify a little bit. So let me write sine 4 pi by 3 can be written as pi plus pi by 3, and the value of sine pi plus theta is minus sine theta, so it will be minus sine pi by 3, and minus sine theta can be written as sine of minus theta, that means sine of minus pi by 3. Now sine inverse of sine theta is theta, that means we can write this as minus pi by 3, and pi by 3 belongs to its principal value range, that is minus pi by 2 to plus pi by 2. So that means the value of this first term is minus pi by 3. Now let us try to find out the value of cos inverse of cos 4 pi over 3. So for that, let me write cos inverse cos 4 pi over 3. Now again, 4 pi by 3 does not lie in its principal value range, so we need to modify a little bit. So we can write cos 4 pi by 3 as 2 pi minus 2 pi by 3. If you simplify, you will get back to 4 pi by 3. This will be equal to cos inverse of cos of 2 pi by 3. 2 pi by 3, because this lie on its principal value range. I have to add this two values, that is 2 pi by 3 and minus pi by 3. So my answer will be equal to minus pi by 3 plus 2 pi by 3, and on simplifying we will get pi by 3 as my answer. That means option D is the correct answer here. Number 7. If A be a matrix of order 3 by 3 and determinant of 5 adjoint of A equals to 5, then we need to find the value of determinant of A. So for this we need to know the properties of adjoint of a matrix, and here I need two properties. So the first property which we should know is that determinant of any scalar k times A will be k to the power n determinant of A. And the second property which we should know is that determinant of adjoint of any matrix A will be equal to determinant of A to the power n minus 1. Here n means the order of matrix, and in our case the value of n is 3 because the matrix A is of order 3 by 3. Okay. So now let us use the first property. So what is given here? Given determinant of 5 times adjoint of A equals to 5. So using the first property here, which I have written, I can write this as 5 to the power n. N means 3 here, and determinant of A, that is determinant of adjoint of A equals to 5. I am using this first property. So here it will be adjoint of A equals to 5 divided by 5 cube. So this implies adjoint of A equals to 1 over 5 square. Now again, here I will use the second property, that is determinant of adjoint of A can be written as determinant of A to the power n minus 1. So here in place of adjoint of A, I can write determinant of A to the power n minus 1, that is 3 minus 1 equals to 1 over 5 square is 25, and this implies A determinant of A whole square equals to 1 over 25, and hence the value of determinant of A will be equal to plus minus square root of 1 over 25, that is 1 over 5. That means the correct option for this question is option number B, that is plus minus 1 by 5. Question number 8. Let A be a matrix of order 3 by 3 such that A square minus 5A plus 7I, I means the identity matrix of order 3 here, equals to 0, and 0 is the 0 matrix of order 3. So there are given two statements. We have to check which one is true, which one is false. So we will start from the given equation. So here it's given that now in the statement 1, it's given A inverse. So I need to find the value of A inverse using the given equation. So for that, I will multiply this equation with A inverse on both sides. So it will be A inverse of A square minus 5A inverse of A plus 7A inverse of I equals to A inverse of 0. Now this A inverse of A square can be written as A inverse of A times A. I'm just writing A square 2 times A times A minus 5 of A inverse of A is identity matrix plus 7 A inverse of identity matrix is A inverse only equals to, and A inverse of 0 matrix is 0. So this implies now A inverse A is identity matrix into A minus 5 times I plus 7 A inverse equals to 0. This implies I times A is A only minus 5I plus 7A inverse equals to 0. Now I need to find the value of A inverse. So let me keep the A inverse term here and the other terms on the other side, that will be 5I minus A. And hence I'll get the value of A inverse as 1 by 7 5I minus A. That means looking at the statement 1, the statement 1 is true. That means this statement is true. In order to check the statement 2, there is A cube. That means first I need to find the value of A cube and I have to check the statement 2 is correct or not. So for that, let us multiply the given equation by A on both sides. Then it will be A into A square minus 5A into A plus 7A into I equals to A into 0. So this implies A cube minus 5A square plus 7A equals to 0. That means the value of A cube here is 5A square minus 7A. So let this be our equation 1. Now let us check the left hand side of statement 2. So let me write the left hand side of statement 2. So in left hand side of statement 2, it's A cube minus 2A square minus 3A plus I. So this can be written as, now using equation 1, in place of A cube I can write 5A square minus 7A minus 2A square minus 3A plus I. So here it will be 5A square minus 2A square is 3A square minus 7A minus 3A is minus 10A plus I. Now this will be equal to, now again here it comes 3 times A square. So I need to find the value of A square using the given equation. From here we can write A square as 5A minus 7I. So in place of A square, let us write 5A minus 7I minus 10A plus I. So it will be 15A minus 21I minus 10A plus I. So it will be 5A minus 20I, and hence taking out 5 common, I will get A minus 4I. That means this is equal to right hand side of statement 2. That means the statement 2 is also true. So the correct option for this question would be both statements are true. That is option number C. Number 9. If A is a skew symmetric matrix of order n, then which one is correct option? So for this, we should know what is a skew symmetric matrix. A skew symmetric matrix is a matrix where all diagonal elements are 0. This is the matrix of order 3 by 3, and if this would be a skew symmetric matrix, then all the diagonal elements should be equal to 0. So here, if you notice, the diagonal elements, the I and j are equal. That means that is a11, a22, a33. So all these values have the same numbers, that is I and j are equal. So here the option C is the correct answer, because if A is a skew symmetric matrix, then all aij are 0 when I equals to j. So hence option C is the correct answer for this question. And what is the property of skew symmetric matrix? That all the mirror elements, for example a12 will be equal to negative of a21, and a13 will be equal to negative of a31. Similarly, the mirror element, that is a23 and a32, are equal but negative of each other. So we should know that property also. Okay, question number 10. The system of equation will have no solution. That means the question has given that this system of solution has no solution. That means this is inconsistent. And if the system has no solution, then we have some properties. So before that, let us assume this first matrix as A, the second matrix as X, and the third matrix as B. Hence, the given equation will look AX equals to B. Now, if this system has no solution, then there is a property that determinant of A will be equal to 0, and adjoint of A into B is not equal to 0. So now if I try to solve this determinant A, I will get the value as equal to 0. That means if I try to solve the given determinant, then I will get the value of A equals to some number here. But looking at the option, my correct option would be either option B or option C, because there the value of A is given equals to, and in option A and D there it is given not equals to. So either my correct answer would be B and C. So A is not the correct answer, B is not the correct answer. Okay, so here I'm not actually solving the determinant of A. We can do directly also. Okay, and if you see the next property, that is adjoint of A into B not equals to 0. Now if I try to solve this in equation, then you will ultimately get small letter b not equals to something, because if you look at the matrix B, there is the unknown small letter b. So if I try to solve this in equation, you will get the value of b not equals to something. And now let's look at, back to the option. Option B has A equals to -5, B not equal to 5. And in option C, there is A equals to -5, B equals to 5. So obviously then option C is also not the correct answer. My correct answer is option B, where A equals to -5 and B not equals to -5. We can actually solve this determinant and find the value of A and B. Okay, but here if we know the property, then we can directly select the correct answer.